Welcome back, everybody. So let's go ahead and jump right in to Chapter 2. We're going to be discussing functions and their graphs, as you can see. Okay, so Section 2.1 is just about functions. Our main objectives here are to describe what a relation is. This is a technical term that's related to what a function is, how to determine whether a relation is a function, what function notation is. We're also going to do a specific computation involving functions called a difference quotient, which is related to calculus. This is pre-calculus after all. Discuss what domain of a function is and how to compute sums, differences, products, and quotients of two functions. And what I want to stress, by the way, is that the difference of functions is not the same thing as the difference quotient of functions. Is the quotient of functions the same thing? Not exactly. Difference quotient is something kind of technical. Okay, so what is a relation? So if I have a bunch of stuff called the domain and another collection of stuff called the range, a relation sort of says if I have something in X, then I can assign to it something in Y. And that's just a relation. Things in X get assigned to at least one thing in the range Y. So we like to think of these as little assignment machines. If you input certain X's, it outputs what is it related to. Okay, and relation notation just uses this arrow, sort of given down here. But we're not going to talk a whole lot about relations. We're really just trying to get to functions. But for example, you could have a relation between maybe buildings and people. And a building is related to a person if that person lives in that building. So any given building could be related to no people. There are buildings that no one lives in. Or it could be related to many people because there are certain buildings that many people live in. But to each input, a building, we assign 0 or many outputs, people. And so we are relating buildings to the people who live there. Or you could have, to every number that you input, you relate the numbers that are smaller. So 2 is related to 1 because 1 is smaller, but 2 is also related to 1.8 because 1.8 is smaller than 2. So a relation, you just assign inputs to outputs, and you can have lots of different outputs corresponding to any given input. Okay. So this just sort of goes through a lot that we had on the previous page. You can have a verbal expression of what a relation is. You can also have some sort of numerical relationship. You can discuss these things graphically, like in this picture over here. We have graphically drawn arrows relating things in one set to another. And this is also sometimes called a mapping. So here we've got some sort of object moving, and at each time we relate to it. At each time that passes, we relate to it how high it is. So at time 0, it's 20 meters in the air. At time 1 second, it's down to a height of 19.2. By the time we've hit 4 seconds, it's only at 7.2 meters, and so forth. Just a way of relating one thing to another. Okay. So first example, a verbal description. In 2010, the average cost of gas was $2.78. In 2012, it was $3.62. In 2014, $3.36. In 2016, it had come down to $2.14, and in 2018, it was back up a little bit to $2.72. Okay, now it's actually lower again. So if we use years as input and price as output, what's the domain and what's the range? So pause for a second and think. Okay. Can you express them as pairs, where you write the input first, comma, the output second? Can you express it as a mapping, and can you express it as a graph? So let's go through all of these. So the domain are the years that are given to us. Now we may have data for other years, in which case the domain might include other things, but in this problem we were only given data for 2010, 2012, 2014, 2016, 2018, and correspondingly the only data we have for range is 278, 362, and so forth. Okay. If we want to write them as ordered pairs, since the average price in 2010 was 278, we would write it as an ordered pair 2010, 278, excuse me. and so forth. This pair here, for example, tells me in 2018, the domain element 2018, the corresponding range element is 272. In other words, in the year 2018, the average price of gas was 272 a gallon. Okay, we could also draw it as a mapping where we list out elements of the domain, we list out elements of the range. They've done it in increasing order on both, but honestly, you can do it in whatever order you want. You just draw the arrows to match them up. So this arrow here, for example, tells me that in the year 2010, the average price was 278. You can also then plot these ordered pairs. Remember, we had the ordered pair, for example, 2010, 2.78, which you could then graph by going on the x-axis to 2010, on the y-axis to 278, and plotting this ordered pair. And then these pairs here, these points, sorry, correspond to the other ordered pairs in this relation. Okay. This is not a long video, but I'll stop here because functions aren't important. Okay, so that's really all we have to say about relations. Functions is where the real meat is. So come on back for that video.